The DataGrid control is a Spark component which displays data in columns and rows like a spreadsheet. In this video, you will learn how to bind data to the DataGrid control and then define which data fields to display in columns. Next, you will combine two data fields into one column display, and lastly, you will format the column data using a formatter component. This is the DataGrid control that I will implement in this video. The data provider that is bound to the control has much more data in it, but I will only display 3 data properties in the 2 columns that you see here. The first column concatenates the first and last name fields together, and the last column displays the higher date field based on a date-time formatter definition. The Spark DataGrid component is a skin around the Spark grid control. It can show multiple columns of data and can include columns that are editable. It displays column headings above a scrollable grid of cells organized in rows and columns. Some of the DataGrid control features include interactive column width resizing, control of column visibility, cell and row selection, single and multiple item selection modes, customizable column headers, cell editing, column sorting, custom item renders in editors, custom DataGrid skins, and smooth scrolling through large amounts of data. You will learn how to use many of these features in this video and the next. This is a code sample for how to implement the control in MXML. Data is provided to the DataGrid control as a complex collection of objects with multiple name-value pairs. You use the data provider property to pass this collection of objects to the DataGrid control. The data provider contains the data model for the control and consists of a list of objects called items. Each item is displayed as a row in the DataGrid control. Remember from previous discussions that the best practice is to bind the data provider property to an instance of the array collection or array list class. Both classes are watched in binding statements, but the array list class is lighter in weight and is typically used when you are not implementing any advanced sorting of data. On the other hand, you must use the array collection class for column sorting. Each property in the array list or array collection instance is displayed in a column of the DataGrid control. By default, the columns are displayed in alphabetical order, and the column headers are set to the element names in the dataset that you defined in the data provider property. This is the starter application file for this video. You can see that this HTTP service call retrieves employee information from a local XML file in the data directory of the project. The result handler for the HTTP service call uses inline ActionScript and the last result property to populate a class property named employee list that is an array collection instance. Below this label control, I'm creating a Spark DataGrid instance with a data provider property that binds to the employee list array collection instance. When I save the file and run the application, you can see that all the data from the XML file is displayed. Note that by default, I can click on a column header to sort the data. Also note that the header text for each column is the name of the associated node for the XML file. Now I will show you how to add alternating colors to the rows of the DataGrid control. Back in the main application file, I'm adding the alternating row colors property to the opening tag of the DataGrid. I'm setting the value to £FFFFFF and $CCCCCC, separated by a comma within array brackets. Note that you can add more than 2 colors, but I want to keep this application simple. I'm saving the file and running the application. You can see that the rows of the data grid now display alternating row colors of white and gray. If you want to modify the default display of the data grid control, then you must create an instance of the grid column class for each column of the data grid control. When you explicitly create each column, you can limit the number of columns to display, set the order in which they are displayed, change the header text, and control the formatting of the column content. This is a code sample for how to implement the column in MXML. To use the grid column class, you first create a columns property for the data grid control. Within the columns property block, add an array list or an array collection instance. Remember that you should use the array list class if you are not implementing any advanced sorting of the data. Then within the array list or array collection class, you create one or more grid column instances that reference the data field from the data provider to display along with the header text property for the column header. I am turning this control into block syntax and then creating a columns property inside of the data grid tag block. Remember that the data provider property contains the data model for this component. The column displays are the view. In other words, all of the data is stored in the data provider property, and you are merely defining which pieces are exposed via the columns. Within the columns block, I'm adding an array list block. Inside of the array list block, I'm adding a grid column instance with a data field property value that points to the last name field of the data provider. I'm also adding the header text property with a value of name. I'm creating a second grid column instance with a data field property of higher date and a header text property set to the value of higher date. When I save the file and run the application, you can see that there are only two columns of information displayed in the data grid control. Notice that some of the content within the name column has been cut off. I will show you how to fix this later in the video. I would prefer that the first column display both the first and last name. To do this, I need to use the label function property to reference a user-defined function. The label function is a property of the grid column class that specifies a user-defined function to format column data. Note that you do not use the parentheses in this function name since it is a reference to the function, not an invocation of it. The label function property is called once for each row in the data grid control and can use all the data for the entire item, not only the data in a column's data field property. When you create a formatter function, you must specify two arguments for it. The first argument is an object instance that is traditionally named item and represents all of the data in that record of the data provider object. The second parameter is traditionally named column and is data typed as an instance of the grid column class. It represents the name of the column on which this function is being called. You will use the return statement to send back a formatted string. At the end of the script block, I am creating a private function named employee name that returns a string variable. The function takes two arguments. I am naming the first argument item and data typing it to the object class. This function will be called for every row in the data grid control. Each time it is run, the data grid control passes all the data in that one row to the function. This item argument represents all that data in the one row that is currently being evaluated by the function. That means that within the function, you can use this item object to reference multiple data fields for display in the column. I am naming the second parameter for this function column and data typing it to the grid column class. This column argument references the name of the grid column instance that calls this function. I will show you how to use it effectively in a few minutes. I'm typing return and adding the item.firstNameValue concatenated with a literal space, and then the item.lastNameValue. Back in the DataGrid control, I'm deleting the data field property for the first grid column instance, since this references one specific field. I'm replacing it with the label function property and referencing the employee name function. When I save the file and run the application, you can see that the name column has the first and last names for the employees displayed, but the width for the column isn't large enough. You can set the column widths in a DataGrid control by adding the width property, but an alternative to this method, and a better practice, is to use the typical item property. The typical item property allows you to specify example data to set the widths of a DataGrid control's columns. You must add an instance of the data item class to the typical item property to define your example data. The data item properties must match the values you specify for the data field properties in the data grid. You should provide a value for each property that is representative of the data because it will determine the width of the column. If there are two data fields used in one column, then the column widths account for both their typical item definitions. This code shows an example of how to implement the typical item property within a DataGrid control using a data item instance. Above the columns block in the DataGrid control, I'm adding a typical item property block. Within the typical item block, I'm adding an instance of the data item class. And to the data item instance, I'm referencing the first name data object and setting its value to Christopher because it is a string that is longer than any of the data values. Next, I'm referencing the last name data object and setting its value to Winchester. Finally, I am referencing the hire date data object and setting its value to 12/31/2011. When I save the file and run the application again, you can see that the columns fit all the data. The first column is now as wide as it must be to fit the name Christopher Winchester. Next, I want to improve the display of the hire date field by applying a flex formatter to the data. To do this, I need to use the label function property again to reference a user-defined function. In this case, I'm naming it date format. Remember that formatters may affect the visual display of an element, but they are not visual elements themselves, so you should create them in the declarations block. You learned about formatters in day 3 of training. I'm creating a date time formatter instance below the HTTP service object and giving it an ID property of employee date formatter. I'm also applying the mask via the date time pattern property that has a value of d-mmm-yy. This will always display the day as a 1 or 2 digit value, the month as a 3-character abbreviation, and the year as a 2-digit value. After the employee name function in the script block, I'm creating a private function named date format that returns a string variable. The function takes 2 arguments, the item and column, like this one above. So I'm just going to type item :object, comma, column, grid, column. I'm typing return and then referencing the employee date formatter instance, and then using its format function and passing it a value of item.hireDate to format the hire date. When I save the file and run the application, you can see that the hire date column now displays the formatted date. The function I created worked just fine, but only for the hire date column. In many cases, you will want to have a generic function to handle the formatting on multiple data columns. So instead of using a reference to a specific column name, you can reference the data field property of the grid column class. By doing this, you will avoid having to write multiple column-specific functions. Here, the data field property references the name of the data field property associated with the column you are referencing. Note that in this code, I have hard-coded the hire date field in the format statement. Remember that the column argument represents the name of the column on which this function is being called. If you look at the grid column instance that calls this function, you can see that it is displaying the hire date data field. This means that the column object is the hire date field. I am updating the hire date reference in the format statement to reference the square brackets, which will allow me to evaluate a dynamic variable. In this case, I'm evaluating the column.data field property. This syntax translates into this statement. Look into the row of data and find the column that is calling this formatter, and then apply this date time formatter instance to it. This is slightly more code, but it is also more flexible code. This change will allow you to use this same date format function for other columns of the data grid, because the column.data field will now always refer to the proper column. When I save the file and run the application, you can see that there's no change to the application display. For your next step, work through the exercise titled Using the Spark Data Grid Control.